Hello and welcome to today's Thwack Camp session on the differences between observability, which a lot of admins are talking about, and monitoring, which if you're attending the session, you probably already do well. I'm Dan Kuebrich, an engineering director for SolarWinds Cloud, and with me today is Head Geek Patrick Hubbard.
Yeah, and thanks again, Dan, for being here. We're really excited about this session because we're pretty sure that you all are seeing a lot of articles and webinars on achieving observability, and we're not so sure that it's really like PCI compliance. We don't think that you just do observability.
Absolutely. There isn't just a playbook or rule book for this. A disciplined approach towards observability will be a huge help, but it really gets lost in hype right now, especially, it kind of feels like the new DevOps. Well, according to Wikipedia, which has definitions for a lot of things, observability is a measure of how well we can infer the internal states of systems from the outputs they make. Simply put, the difference between monitoring and observability is the difference between black box and white box, between alerting on symptoms and being able to debug the problems that are causing those symptoms. And that's what everyone's hyped up about.
Yeah, and I love where you're going with this. I mean, just being able to unpack the difference between black box and white box monitoring, right? So let's in this session talk about a couple of things, right? First, let's talk about that never-ending cycle of the novel error that causes more and more new monitoring. We'll go over some new techniques to consider, and especially how to use the tools that you already have a lot better. We're going to talk about clamping down on spurious logs. And I think the last thing is I really want to pick your brain about whether or not tracing is actually helpful for everybody who's watching, or maybe just cloud and big operators. I'm not sure on that.
Sounds good. Let's get started.
OK, so let's start with that problem of the never-ending loop of new monitoring.
In my time in operations, I described most of what I did as monitoring. So there would be new systems stood up, we'd set up monitoring and respond to alerts. And the alerts were typically on the symptoms of problems. So a disk got full, key process died, something like that. And you hope that there's a runbook for that, right? Because the problem isn't, like the root cause of the problem isn't like, oh, the disk got full, something filled up the disk. That's what's actually happening there. And so you'll go and fix that problem. And that's really kind of the reactive symptom-based monitoring approach, right? And if you could anticipate every problem that would happen in your systems, then you could set up specific alerting for each one. So like, oh, well, when it emits this signal, that means this thing happened. Of course, it would be better to fix it, but sometimes you do the monitoring approach. Well, my systems are too complex for that, and I bet yours are as well. There's all sorts of new failure modes that emerge, and that's because they're complex, they're changing all the time, so we're releasing new versions of applications. People are using them in different ways. People are SSHing into machines they shouldn't be SSHing into. All sorts of things are going wrong, and so those alerts that you're going to get, they will have different root causes over time. And this is where observability comes into play. So we used the Wikipedia definition earlier, which comes from control theory. And so in that, you really want to be able to know not only kind of what the symptoms of the problem are, but what's going on inside the machine that's causing those symptoms. So ideally, the signals that are coming out, what we're getting aren't just those, disk is full, but also something that helps us know, like, oh, it's because, this queue is getting backed up, or, this worker went crazy, something like that, right? And that's where we start to get more into observability, and we turn those black boxes we're monitoring into more white boxes.
Right. Well, it's almost like admitting that observability is the point of why they hire us to do operations in the first place. Because to your point about, you said, being able to anticipate all the potential problems. If you could anticipate all the potential problems, you wouldn't need anyone in IT, right? You could automate all of that out. And so we literally are hired and retained and trained and get hardware and software in order to be able to answer the unexpected. That is what we are there for. So the idea of starting conversations with management who spend an awful lot of a budget to make sure that we're there on observing, like, let's see, let's gather what we need and actually have it, because that is allowing us to answer all of those novel questions, to address something that's never happened before, because that's mostly what we deal with all day.
And it's a tough job. I mean, we need help, and that's why we set up these systems and work with people and our software to make that magic happen. So there's been a lot of talk on the the blogosphere, the tweets about the 3 pillars of observability. You've probably seen some of this.
I've generated some of that.
Well, okay, there you are. I'm talking with the expert here. And these 3 pillars are usually defined as metrics, logs, and tracing. So the 3 pillars of observability, you might call those 3 pillars of monitoring. Again, it's on a spectrum, but each one of those is a key component of monitoring these systems, and you're probably already doing some or all of that. I would love to dive into each one of those in a little bit more detail and just talk about, where we can get a little bit more from monitoring into observability to help stay ahead of that, error treadmill.
Right, and what I love about this is a topic that obviously SolarWinds tools are designed to really facilitate this, but this session should apply to you regardless of what tools you're using. So this is best practices that you should be able to apply no matter how you're managing your operations.
Absolutely.
All right.
Let's start with metrics.
Okay.
All right, so let's take a look here. Now, whether you're using SAM, App Optics, which is what we're looking at here, NPM, you're just using CloudWatch metrics, Graphite, whatever it is, you're going to probably start by looking at the performance of the actual infrastructure that's running on. So here, for instance, we're looking at all the different hosts that make up particular production environment, all the different applications run on top of this. We're pulling in data from a number of different sources, but our KPIs are those basic indicators, kind of the pulse of the system, right? CPU, memory, disk and network I/O, and so on. And we probably want to be able to trend that over time. If you see a sudden increase in disk I/O, something like that, then maybe you'll get an alert, or maybe you'll want to dive deeper. Now, of course, this is symptom-based alerting. It's great. It's necessary. You have to have this kind of thing in place, but once you have that, you'll probably want to dig into a little bit more context, like what is running on this instance, what services or applications, is it stuff running in containers there, what's the operating system, basically get a little bit more context about it. So the first thing you can do with metrics is have them in some context that helps leverage them a little bit more, so you're not jumping all these different sources.
Right, and I was going to say, for those of you who aren't familiar with App Optics, one of the things that's different here is this isn't polling, right? In this case, there's an agent that's actually sending this data from the client.
That's right, and the agent can actually pull in data from a bunch of different plugins as well, or we could just grab that data from, say, CloudWatch if you're running in Amazon, something like that.
Right. Well, what I like though too is if I think for a lot of our viewers, they're used to sort of the network performance monitor or server and application monitor dashboards where you would have a node details page, for example, right? And it would give you the base information about that system. Well, here's that same thing. Like in this case, right, I've got my distribution, I've got number of CPUs, so the MAC address, the rest of it, but so the information that would normally appear as a part of a node details view is available for each one of these again. But it's just a slightly different presentation, but it's that same data. But in this case, it's being pushed to App Optics instead of being pulled by the central.
Exactly. Different methodology, but the same approach. And so, again, what we're talking about here is techniques, works across a lot of different software. Now, speaking of putting stuff in context, a view that I really like for understanding outliers is our heat map of the infrastructure's performance. And so here, we're looking at CPU utilization across all of our different hosts. We could look at load, network performance, and you can start to group that by different attributes of the data. So for instance, maybe I'm seeing a bunch of connectivity errors, and I want to know, is that isolated to a particular rack, a particular availability zone, something like that. So here I've grouped on availability zone. I can see maybe one of these is experiencing no network traffic or massive numbers of errors, packet loss, stuff like that. That would quickly narrow it down. In this case, everything's running fine, so no worries about that. Here I'm looking at the performance of these instances across their role. And so I can see that typically things that are carrying the same workload are performing similarly, but there's actually one host here that has a dramatically higher load, and so I'm curious to find out more about that. And so here, we want to go again from those symptoms to understanding what's going on underneath it. I can see that there's a couple different services running on this hardware, and a lot of different containers. And so maybe we want to start to understand, well, what are the applications running on this actually doing? Maybe there's something going wrong with those. And for that, I would love to dive into some APM data that's being gathered from the application running on this particular host.
Okay.
So APM data, we're actually looking inside the application. There's an agent that you install. It doesn't require code modification for .NET, for Java, for PHP, and so on. And it'll start to break down the performance of the application, both by kind of the workload that it's under, so how many requests per second is it getting, stuff like that, but also what it's doing inside. So for instance, this particular application, we're seeing that it spends maybe about 40 milliseconds on average processing a request, but the majority of that is in a MySQL database. So we can already say if there's a spike in latency, is it the application, is it the database it's talking to, stuff like that. So that's getting more from monitoring into observability, because I can start to chase these problems one step farther than I could before.
Yeah, and it also helps turn that into a question, right? Because if I'm looking at infrastructure and shared resources, right? The pile that either is what's sitting in your rack or the resources that you've assigned in a cloud, for example. Well, milliseconds latency for overall, let's say, TCP connect time or something else, it's going to be based on the infrastructure. If I have a lot of latency based on this database instance, this is my SQL database, is that tuning? Is it really a resource constraint, or is it the application itself? So the idea of like, I'm not just going to start with a number that says this is the number of milliseconds and flip that over to my application team, the dev team, or the database team, for example, but instead say, this might actually be an application issue. This might be a design problem. This might be something more than just noisy neighbors. So the idea of thinking about it at a larger level, like at that first, I'm not just going to redispatch this to somebody else. This might actually be application-based. So thinking about overall application awareness, you start with those questions at this level.
Yeah, that's actually a great example, and when we come back to tracing a little bit later, we'll see about how understanding the interactions between the application and the database is key to understanding performance. You've also hit on one of my favorite things about monitoring, which is it's very hard to actually answer all the questions. Usually you end up with a couple more. And so, as you look at more and more data, you understand the system better, and you become more curious. It's like this recursive thing where you end up just learning everything about what you're working on.
And it's collaborative. That's the other thing, is that when you're talking about seeing, about the gathering data, it's to support a conversation that you're going to have with someone else on your team, because it usually isn't something that you can solve yourself. In a small organization, you might have to solve it yourself, and there's nobody else but you and Google to actually make that happen, right? But more often than not, you're working with someone else. So being able to have the data to back up that initial contact as a open conversation for solution, as opposed to I'm just going to send this off and I'm not going to worry about it anymore, or mark it closed, not my problem. That doesn't happen.
Yeah, exactly. And there's all sorts of ways you can kind of examine and pivot this data. Does it have to do with maybe the application started getting a bunch of different types of HTTP requests? In this case, we were looking at a web application. It exclusively receives post data. That's pretty consistent. Low rate of 500s, just a single type of transaction it processes. Here, we're breaking that down by host. I can actually see, interestingly, only one of the hosts has errors that it's exhibiting. So already, again, we just started looking at this service. We're kind of interested in the load. Now I'm finding more questions that I want to dig into, but I'm also starting to find some answers about what might be happening or what might not be happening. So for instance, load is very consistent. The types of requests that are being processed seem pretty consistent. So I think maybe something is going on based on this with the hardware, or maybe with the application on that one instance. So we're starting to go from just, again, those metrics about what are the symptoms to, okay, I'm ruling some things out, I'm drilling down.
Well, and you touched on something interesting. When you look at this chart here for error rate, right? Like we're below, what, 0.25% errors of total transactions, which is what it's showing us here, right?
Yep.
Is that these are the kind of metrics that aren't a part of traditional monitoring. So the idea of being able to have a conversation with management that says, yeah, I know you've seen some errors, but I can chart that like anything else, and I can chart that against the delivery and the performance of everything else in my application. And so that's an example of the sort of metric and data that is a part of the observability conversation, which is not part of traditional monitoring.
Yeah, that's right. And setting a kind of error budget or certain expectations is a great way to start to manage your job and your relation with the business.
Yeah, and we talked about that in the microservices session, so definitely check that out too.
Fantastic. Speaking of connection to the business, so we have been looking so far at stuff that is tied to the infrastructure, that's tied to and gathered automatically from the applications. We can actually start to get custom business metrics in this platform as well, because maybe that's a valuable signal for alerting or for debugging. And when we start to do that, there's some ways that we can pull it. We're going to look at pulling data from logs in a second, which is fun and easy. But you could also start to instrument your code. And this is where you can collaborate with people building the applications to have them expose signals that will help you debug those systems and help them debug them as well. You probably have some way to set up custom dashboards, to put custom metrics into your observability or monitoring system. In this case, we've got a bunch of stats that our data engineers thought would be useful about one of the back-end systems. And what this helps us do is, again, go from, oh, this queue is backed up, this high-level measurement is looking bad, to what could be going wrong inside or with the type of data that the system is processing that's causing this backup. And so all of these are custom metrics that are relevant to the particular system, and we can actually extend this to things that become relevant for the business in terms of checkouts, in terms of transactions, user sessions, which, by the way, turn out to be pretty powerful learning signals for high traffic systems as well.
Average sale price at checkout, number of items in cart, number of items browsed, average number of items considered, that kind of thing.
Exactly. And so that's, again, these types of things could help you realize, oh, there must be a problem with, adding stuff to the cart because that plummeted at the same time that, we have this other, latency signal, or that, this system is reporting failures. So
do you have a lot of customers that start using custom metrics, especially for things that maybe are non-traditional targets for ops, like mobile, for example? So let's say you have an application that's available through a website. You also have a mobile app version of it, which is all based on APIs. And so you've got customers that are sometimes in an environment where the network is great, and sometimes they're in environments where it's not. So it's still affecting application performance. But do you find that a lot of times they'll use custom metrics to be able to help actually break that down and analyze it, so that instead of saying, hey, this is worthy of additional investigation because this is performing very poorly, and then you have the data to say, well, actually that user is on or they've fallen back to 3G, very, very far from an antenna on a very, very slow device. Does that make that a little bit easier to kind of sort out whether something is actually not performing as expected?
Yeah, that's a great point, because one of the things we can do with custom metrics is start to associate all of this information as tags on the data. So provide a bunch of different dimensions, and maybe the dimension is the connection type that's submitting the data in your example, or it's customer IDs. So if you have a multi-tenant system, you start to get complaints, is a problem across one user or all users. Now you can break that data out and start to answer questions about what different parts of your user base are being affected. And that's just another tag you put on your data, and now you can quickly ask and answer that question. Metrics, we think of this, it's a very kind of, everybody knows how it works, old school concept, but there's a lot you can do with it, and it's a little bit of a trap to get stuck with just the monitoring-based approach. There's actually a lot of fun stuff you can do when you start to get into custom and APM metrics, as far as looking into the application, being able to debug faster.
Okay, so I want to admit to something, and I think many of you, I think many of you have seen, and the last SolarWinds Lab episode, I pulled out the Raspberry Pi, the Pi Lite device, and I put it up here, and I kind of talked about that. But this is a chance to really talk about this a little bit more in depth, because that app, it's essentially a continuous integration, continuous delivery pipeline for IoT. So the idea is you go in and make code changes on the device. Each one of those things is running Docker, and then it's using Watchtower and a couple of other things in Docker Hub and some other techniques to move things around. But the idea being, I make changes to my code, I check them in to GitHub, and then I do a pull request. And as a result of that pull request, Jenkins automatically does a build, pushes the new Docker image out to the distribution point, and then the Pis pull that down, one of the Pis pulls it down, a staging Pi, and starts running that application. Now, if I was thinking about this from a normal sort of monitoring perspective, that would be a lot, right? So first, am I going to set up Elasticsearch? What am I going to do? I've got to create an endpoint. I'm going to do events. I'm going to do log consolidation. I'm going to do a lot of different things. Well, this is the view, and I got to show this at Cisco DevNet. And this is the thing that really converted me to thinking about this approach, because in this case, there's a whole bunch of them running, right? So up here in the upper left-hand corner, I've got the number of Raspberry Pis that are connected. And then I've got information about how much memory, CPU utilization, all the resources that they actually need, wherever they are in the world. And I'm also getting read, write, and storage. But down here, I'm getting the change in the rate of change of the number of animations in each one of those aggregated together, right? This is the kind of thing that once upon a time would have kept me up at night. But when I stopped thinking about monitoring and then realized, no, I'm trying to observe these. So I'm going to combine, there's an agent installed on H1, which is actually sending me the information about, in this case, memory utilization, CPU. And it's actually, this is based on collectd because it's ARM, right? But it's also combining custom metrics that are coming out of that application, which is written in Go. And then there's all the pipeline information that's a part of AWS, where Jenkins is running, and a couple of the other elements that comprise the deployment pipeline. Those are both running agents. So I installed a couple of agents. I added 2 lines of code to the Go, and that builds this dashboard for me. So that's the sort of thing where you start down the process in operations of, this is a problem I can solve, and then you get to, I have to build a whole infrastructure to be able to monitor that if I'm using traditional means. Well, the reality is, if you're willing to include traces and logs and custom metrics along with regular infrastructure polling, you can pull all of that together in one place. And so if you're thinking in terms of observability instead of monitoring, it makes that a lot easier, and you'll think about things that you haven't considered before.
I've never thought about having animated lights monitor their cycle time. And if I were handed this, I wouldn't even know where to start. So I appreciate, as a potential operator of your lights, all the observability you put into the system, right? Because now I can understand what's going on, not only just the memory utilization and so on, but a little bit more about what it's supposed to be doing. And I do feel like the animated lights will keep me up at night, regardless of whether I'm getting paged or not. Well, that's a fun way to wrap up metrics. Should we talk about logs next?
Ooh, let's talk about logs.
Actually, I want to take a step back to look at some logs that were kind of intriguing earlier. So we've been looking at the performance of this particular service and just happened to notice, weird thing, errors only being observed on one of these hosts. Mm-hmm. So I kind of wonder what those errors are. I'd like to drill down more. And in fact, looking at information about this host, I saw that we can jump to view those logs in Papertrail. So we happen to be using Papertrail to monitor our systems. Let's just jump right over there. And
for those of you who aren't familiar with Papertrail, think of it as a giant log tail in the sky, right? Send everything to it. It's going to pull it all together into one feed, and then you can search out everything that you need.
Yeah, and that's actually what I love about it, which is it's really similar to the same experience of just going and looking at a log file on a machine, except I don't actually have to connect to the specific machine. I can search across a bunch of different machines, a bunch of different processes, all their log files at the same time.
A couple million messages an hour.
No big deal. Yeah. In this case, we've just jumped into the logs from that particular machine across all the different services, and this is live tailing. So we just see everything that's going on the machine. For instance, it looks like we actually had a root session open while we're watching. Mm-hmm. That's exciting. So it's easy to get kind of lost in this. Maybe we should take a step back and think about, what are logs? And so, we talked about metrics before. We're kind of aggregating these counts over time.
Oh, I know what logs are. Logs are a little bit of information that sometimes, if you're lucky, gets persisted somewhere in your file system, and maybe you get to solve problems with it, or maybe you don't, or maybe it goes away. And
yeah, you just kind of stash them away somewhere, right? And hope they'll be useful later. And then you kind of go digging in the logs and looking for the skeletons in the closet. And that's kind of true. The good thing about logs, and the reason we have so many of them, is that every application is going to be spitting them out. And maybe you can tune the log level, but the fact that it's in there, that the developers of that application, whether it was built at your company, whether it's some third-party application, just off-the-shelf software, it's probably got logs, and you'll be turning to those logs when something goes wrong.
Okay, but don't you find that a lot of times in operations, we're kind of balancing, we're trying to find the sweet spot between generating logs that are verbose enough for us to get information that we need, especially if it's a novel error that we rarely see, and to make sure that we catch it the first time and not get in that loop of, okay, I'm logging a little bit, I missed it, so now I'm going to go back and create yet more new monitoring by changing my log level and then hope I can catch it again. Versus we're going to send everything to a single collection point, but then now I've got to worry about scaling out that infrastructure and managing it. So we're kind of like always trying to set our log levels as low as possible so that we don't swell the size of our collection infrastructure, because that then turns almost into big data, this whole nother thing that we have to manage. But then we miss information.
Yeah, and that's the challenge. You can get kind of carried away. Some people might say, well, just put all your data into logs and then parse it out for metrics, which we'll take a look at in a second. And that's great for some things where you just couldn't get those metrics otherwise. Right. But imagine logging CPU every 30 seconds and trying to make your graphs based on that. That's not how you want to measure resource utilization, right? So there's this trade-off. I think for something like Papertrail helps if you don't have to manage the hardware. It makes it a little bit easier, but you still want to be economical about how you're doing this.
Right, and it's also not, because it's not just about aggregation. It's convenient, but the real thing is to be able, to your point, to be able to get actual metrics from that log data.
That's right, and then even go from that metric to the actual kind of underlying fact. Because the thing that the logs give us, like, it's great that the developers put in all this instrumentation we can pull data from. It'll also have, again, information about the internal state of the application that they thought was relevant, and that's where we're going again to observability. So this stack trace got thrown. What's going on inside the application at that time? So I don't know. Let's look for that error, for example. So we're live tailing this log. I'm going to look for errors in the log. And in fact, we see that pretty much there's just this one type of error that's happening on that instance. It looks like it has something to do with our container repository. So we're actually having trouble removing a container from it. And it looks like this is pretty consistent. Maybe there's like a configuration issue on this machine. I want to know if it started recently or not. And so again, extracting those metrics from logs, I just did a search. I can easily turn it into a trend line over time and say, is this something that just started recently? And in fact, I don't know, it looks pretty consistent to me. So maybe I don't have to be urgently worried about this if the system's working okay, but I'm concerned maybe it's going to start to pick up over time. So I could take that metric, save the search and set up an alert on it, something like that. Export this metric that I'm deriving from this data maybe to a different system for dashboarding, like into AppOptics, like we were just looking at. So I'm able to get this information a couple different ways, but in this case, I can also drill down and see that exact error message, the context that the application developer thought was useful for me to solve problems here.
And with distributed applications, like the example that we saw before with the PyLights, I use it more as a way of kind of creating a reduced grab bag, right? So there's a lot of things that are going on, but in the case of like software deployment, CI/CD pipeline, I only want to see those events that are related to that, but I don't know what they're all going to be. So I actually did one where I've got a saved search here for all of my pipeline events, right? So that's going to be the play events that indicate, like up here you can see the level and sort of the animation that's playing, but then down here is all of my Jenkins stuff, right? Plus all of my AWS infrastructure messaging. To your point of I'm actually looking for SU events on here because no one should be doing that. If I see a single one of those, I want to be able to raise an alert and do something with it. But in this case, I've got hundreds of thousands of log messages coming in here, but I've now just got it down where I'm looking at not just a single event, but I'm looking at a whole bunch of events, but narrowed within the scope of that application. These are all the events that are related to the log messages that are related to distributing that software. So that sort of is a job function, or at least a application defined set that I can share with other people because it's a saved search.
Yeah, and I'm noticing something else really interesting in here as well, which is we've got a mix of different types of log files as well. So we see Jenkins is kind of spitting out that standard, text line with a timestamp at the beginning, but your PyLight is using some JSON. What's that about?
Right. Well, it's structured versus unstructured data, right? I mean, how often it'd be great if logs were always nicely organized and they were structured and they all had named fields, but a lot of times they don't, especially with packaged applications or maybe some legacy systems. But if you look at this one right here, this docker.watchtower, that's a container that's actually running. It's sort of doing sidecar maintenance and synchronization for Docker Hub. So it looks to see, did an image change, and if so, it's automatically pulling it down. So that's part of the deployment process. But it is kicking out a plain text message, which I still need to parse out. I still want to do something with that.
It's plain text, but it's kind of structured too. Like I'm seeing that there's this kind of key value structure, and so what we really want to do, like obviously we can just full text search this like you do, just grab through it. But if we could parse that automatically or manually, there would be a lot of power to just filter on individual fields or graph those fields or trend them. And we're seeing more and more structured logging. But you actually don't need structured logging in order to get structure out of your logs.
Okay.
Let's take a look at what we can do with Loggly to give a good example of that.
Perfect.
So Loggly is, surprise based on the name, a log aggregator. So like Papertrail, it's pulling in logs from all these different sources. But one of the cool things is not only is it pulling in any plain text you can throw at it, but it's also trying to make sense out of the structure of that. And we can see already in these log lines that we have here, they're kind of being presented as JSON. So we maybe have received JSON, we maybe kind of parsed it out, but we're actually able to interact with that in a much more structured basis. And so we know kind of what are the attributes and what are their values for each of these log lines. And if I want to start to filter, and right now we're looking at logs across a bunch of different systems, but maybe I want to look for this particular client host activity, we now know that we're searching for that IP address just in this particular context of HTTP client host IP. So with this structure, we get some interesting opportunities. Obviously, we see this graphed here as well. But we get some opportunities to interact with the data in higher fidelity ways while still having the raw underlying facts. And we were saying, this is JSON logline. That's kind of convenient. Not all of these have to be structured to begin with. Mm-hmm. So for instance, this particular logline just came in from syslog. And it looks like it's got an Apache kind of access thing going on here. We've got information that came in as logline from this host that looks like this. So again, sure. Apache access
HTTPS.
Log. Yep. Exactly. But Loggly figured out what the relevant parts are to kind of pull out and parameterize, as well as storing the unparsed version, so we can always get back to that.
And that's because it's got awareness. It looks at it and says, this looks like an HTTP log. I know what to do with that.
Exactly. And so there's all sorts of logs that are common. We're good at eyeballing them. Computers are increasingly good at figuring out what to do with them as well, but they're not perfect. And so you can also go in and start to add custom parsing. And maybe you have some funky internal application, something old, perhaps interesting, dare I say legacy,
yep.
that you want to be able to get that type of behavior out of. Well, you can go beyond just regexing every time you want to search. You can actually get it structured.
Well, and many of you know I spend a lot of my time bolting this sort of observability technology on top of legacy, on top of some processes have been running for a really long time, where structured data is not something that the developer necessarily thought of when they started emitting logs. And so it sort of is up to the developer, and you get this really uneven quality of or value of data in each one of those messages. And what I typically do is, you look at the way this is broken out, right? So it's telling us that this is Apache syslog, so it's sort of already given us a couple of tags on this element. But it's also telling us what it couldn't parse. It's giving us the raw message. And so if you sort of think about, like, under syslog, these properties that it was able to extract from that, and then think of unparsed as the leftovers. So this notification section is going to tell you why it wasn't able to parse. Why were there leftovers that it didn't know what to do with? And those are usually what we kind of call derived fields. So you can actually go in and define custom derived fields. If it's regex or something else based, you can actually add that, so that then they just sort of show up naturally under the properties here, under, in this case, syslog. I'd be able to get that last piece of information that got left out of that parse.
And here, we're almost going backwards from observability towards more traditional monitoring, because we have all this great raw data about the internals of the system. Maybe that's the way that we want to get the stuff that we alert on. But we've got that whole spectrum. We can always come back to these log lines, to these events, and boy, it's really convenient when they're structured and you get there.
But that's really the point, I think, here of thinking about observability instead of monitoring. Monitoring says, if I have structured data, I've got a metric, and I've got a metric I can put in a chart, and therefore it's monitoring. But in this case, literally, I see what you did there. You're taking unstructured data, but it always follows a pattern, and turning it into structured data, which allows you to then turn it into a metric and put it into a dashboard. So it's that idea of, I'm no longer limited to just that which I can pull for, or that which comes in structured and is easy to consume. Let the machines do the work, to your point earlier, the hard work of turning that into actual data, and then it's just monitoring data like anything else. Okay, that's enough about logging. I'm babbling and I'm kind of verbose.
You are a little verbose. Did someone set you to debug this morning?
Yeah, probably info would be plenty enough here. But so let's talk about tracing, because that really is a thing that I think for a lot of people in our audience is something that is truly new. It's something that we haven't had to deal with in the past, but is increasingly really important to get a sense for what's going on in our systems.
For sure. Let's take a look at it. But first, we're going to need an application to trace. And here we've got a simple-looking hotel booking app. There's a lot of very fancy hotels at extremely affordable rates.
I was going to say, this is amazing. At fixed prices.
Yes, with many rooms available as well.
Wow.
I'm confident that there's no issues with this system, but what if there were? What if things were going slow, people were having a hard time booking, there was some sort of error that's generating thousands of available rooms? Well, it must be a simple application under the hood, right? And That's the thing. Not so much. We actually have this instrumented with AppOptics, so we can actually see all the different services that are backing this simple-looking application.
So it's not just like a web server with a database. This is multiple different components that are all interconnected that are providing this web interface.
Exactly. And you're probably familiar with systems that are like this, or even more so, right? Now, an application that just is a web service that talks to a database, by the way, I would argue that's a distributed application. You've got multiple different tiers interacting. You can have all sorts of weird performance problems, but the problem becomes way more exaggerated as you start to compound that with additional tiers.
Right.
And so when I'm looking to think about this booking application, what's slow, if it's slow and I just start, say, looking at the logs or looking at the metrics of the web tier only, I might be missing a lot of the pieces behind there. Like, well, is there something going wrong with the booking service or with the pricing service? Is there something that only happens when users go to execute transactions? So, let's start by looking at the performance of one tier, but I really hope I can somehow correlate that data across tiers. And this is where tracing comes in. Instead of having to spot check the performance at individual layers of the stack, we can actually follow a business transaction across all the different tiers of the application to understand why that's not performing well.
So when you're talking about the agent before, what's happening here is the agent is actually putting, I guess, IDs in flight with the transactions and then tracking where they are.
That's right. What we're doing is, for tracing, we will generate a unique identifier for a transaction and propagate that through the entire lifetime of that transaction, whether it takes 1 millisecond and hits 1 or 2 tiers, or whether it takes a couple seconds and it's actually like a little bit of a performance problem for us across 10 tiers. And we want to be able to tile that information together in one place. And so here I'm looking at the performance of this application tier. It looks like we had a kind of performance problem just a little bit earlier. And here's actually kind of that first case where distributed tracing is coming to play. I'm looking at the request per second, for our web tier. I'm looking at the latency percentiles. Like, requests start to get a lot slower from our typical, just tens or hundreds of milliseconds to multiple seconds. And this seems like it's a problem with the application. But is it in this tier or is it somewhere else? And I have a distributed system, so I need to know about that. And maybe I could go look at the logs or look at some of the metrics here. This graph that we looked at earlier that's breaking down the response time of the application by where it's spending its time is actually pretty illustrative, because what I'm seeing here is this application, this tier of the application, its performance never really changed when it was under load, but the booking service started to get really slow. So it seems like there was something going on with that tier. And so already being able to look across multiple tiers of the application is pretty helpful. I'm also curious, whether that affected, all transactions, whether it was about load on a particular transaction. And so here we're looking at all the different types of requests the application is processing. Most of these are code paths. It looks like there's a particular font that we serve as well. And this hotelscontroller.show not only spiked enormously in response time, but also in the number of requests it was getting around then. And it looks like it was kind of performing fine under load for a while, and then something went south. So let's take a look at that in a little bit more detail. And again, here we're seeing that, yes, for this particular code path, for this endpoint, for this transaction, the booking service is responsible for the majority of that impact. So increased load, increased booking service problems. Fortunately, we didn't start to see errors from the application, but maybe users are getting frustrated. They're bailing. They're booking with one of our competitors. I don't like that. I could just jump to the booking service and start to look at the booking service logs, but the booking service kind of thinks about everything from its own perspective.
Right.
It's not really connected to the front end of the application. Which
is the point of a distributed app, is you're trying to loosely couple the parts so that you can make changes easily, and with a monolithic application you couldn't do that.
Exactly, and I love that when we're operating on an individual piece of it, but then when I have to debug it, I love it less. Fortunately, this is where a trace comes in. And so in the background behind all these metrics we've been looking at, we've been gathering a bunch of traces, which are kind of like examples. It's like a log file across all these different services, right? And so we got all the data from that. Here we're looking at kind of a scatter plot, a heat map of our request latency. And so we see our kind of traces from around that time start to get a lot slower, and we have some really slow ones. So I'm just going to grab an example outlier here.
So yeah, so what you're really doing with this view is you're identifying outliers. So sort of size of pile, and then the vertical extent is how much of an outlier it actually is.
Exactly. And it seems like everything got slower around this time. Just, everything is kind of trending up. The tail's getting longer, and I'm particularly concerned by these, outliers that are.
And this is the first
like 5
real
seconds.
sort of blip that you had.
Yeah, exactly. So we'll just drill down on one of these, as an example. And so this came from, around a little earlier today. And here is our trace, which again is showing the path of that request through the entire application. And this is kind of a monster. We thought we had this simple hotel booking application. Now we're seeing all sorts of action happening in these 5 seconds. So let's dive into that a little bit more. So here we can see the full details of the request that was made. So this has to do, on our hotel booking site with a particular hotel page that we're looking at, and it looks like we're doing a search for pretty wide range of available dates. So this is kind of like if we're looking in the logs and we see that, well, I wonder if the application is designed to support that, and we have that information to kind of guide us here a little bit. And the request took about 5 seconds. How did it spend its time? This chart here is a timeline that shows how that request was processed across all the different tiers of the application. For kind of a quick legend to it, we can see that broken down by the different components of the system. And in this case, we're sorting by the total duration. It seems like we spent a lot of the time in a MongoDB database. And as someone who works on the web tier of this application, that's a little surprising because I know the web tier doesn't use that. So does the booking service talk to it? Does some other service? Like here, we're able to tie that all together. And this extends to us actually seeing the individual queries that are being run against that database, how those are performing, how many times they're happening, a lot of times. And we can drill down into that in more detail. I'd like to know how this application is kind of handling it such that we are hitting MongoDB. Is that expected? And so I can actually zoom in on just the beginning of how this request is processed. So from left to right is kind of the timeline, and from top to bottom is the tier of the application, or the layer of the stack that I'm in.
Right.
And so our web front end here, our web tier, is this Ruby application that's running at the top, but the heavy lifting is done by a Java-based booking service on the back end.
Which is talking to MongoDB here.
Exactly. And what this booking service seems to do every time that we call it, it runs a bunch of MongoDB queries. And so we see this pattern where we're calling into it, it runs a bunch of queries. And in fact, these 3 separate calls we're making to the booking service each take a couple seconds. And so maybe I want to drill down and say, okay, well, what is the request that we're making of the booking service? And here we've got that kind of structured key value pairs to help me understand, okay, here's the transaction, this booking info controller was being executed. Here we're passing along that same date range that we saw, and we've also got some IDs about the type of room in the hotel we're looking up. And then that goes down into Spring, the web framework in this case, and we can see all the queries that are being executed against the database, along optionally with the parameters there. So we've really got a good level of debug detail. So we've gone from, I see that we have this interesting performance problem, down to, okay, this is how all the tiers of the system are interacting to create that performance problem.
Well, and what was really helpful for me as I was making the transition here and learning along with the rest of you about distributed applications was the 2 problems that I always have are, how are these things connected? Like what parts are where? You don't necessarily know because they're no longer all contained in one nice packaged application.
And one day that could change.
One day that could change. And then the other thing is this is real data. This is a human being in this case who is actually looking to book a room. So I've got the data that was part of a real transaction. So sample data always ends up being one of those things that's troubleshooting. It's like, well, now I'm instrumented. Now I'm finally going to execute an example query and try to figure the thing out. It's not running in context. So here I can go back in time. I can get the actual data. But this bar here across the bottom, right? So we've got the different layers here. Right? I got Action View, MongoDB, Spring, Java, the Faraday, and then the web server and Rails, right? Is that I didn't have to go separately instrument every one of those applications. I applied the agent to the different hosts that were actually providing that, and it is telling me that this is effectively the inventory of services that make up this application. That was extremely useful for me, because otherwise, especially when you're learning new technology, like if MongoDB is new to you, or this sort of distributed application is new to you, the first thing is, what's the inventory of parts of that application? So this gets through that first step so that you don't end up with that situation where I'm half instrumented and the things that I'm monitoring all look great. Where's the problem?
Yeah, and that's actually a great point, because these monitoring tools, at the end of the day, they're supposed to help you find problems and solve them faster. If they're missing a bunch of pieces, if people have to go and add every last thing, if they have to update configuration when the way the system works changes, that's dangerous, because there's going to be drift. Like it's going to get out of sync. And so for this particular case, we just put in a Ruby gem, we attached a Java agent, and it's automatically parsing the kind of structure of these applications to figure out what's interesting. Oh, here's a connection to a database. Here's an incoming web request. And when someone adds a new database, adds a new JDBC dependency to our Java tier, that'll be picked up automatically. They don't have to think about, what am I going to expose about this? And so that's great proactive monitoring, but also insurance against changes in the system that might start to impact, things that you have to debug.
But I think that's really the point here with distributed applications and tracing, is it sometimes if you're used to, especially monolithic application monitoring, this can seem really impossible for all the reasons that we just discussed. But really, tracing is that magic. It's the glue that lets you be able to turn, again, a set of individual events, transactions into structured data that then you can turn into dashboards, and then they become monitoring just like anything else. Okay, so I think I get it now. Number one, do not freak out as applications become more distributed over time.
Which they already are and will continue to be.
Absolutely. Number two, I think all of you already have basically everything that you need to measurably gain better systems observability, not just do more monitoring.
Exactly. You can talk about monitoring as a discipline, and setting observability goals is a big component of taking a disciplined approach. Each new application, new system, new user group shouldn't require a bottoms-up rethink about monitoring. So if you start by asking, how do I observe this system, rather than just adding metrics in response to errors you see, you'll find that process much, much easier.
Awesome. Well, thanks again so much for being here.
My pleasure. You really need to come out to the San Francisco office more often.
It is pretty choice. That view of the Bay Bridge, that's nice. Okay, well, that's it for this session. And thanks again for being a part of THWAC Camp this year. I'm Patrick Hubbard.
I'm Dan Kuebrich. Thanks for watching.